Alright guys, so today we're going to continue on our solving of systems. Today's going to be 3.5, solving systems in 3 variables. So a reminder that if you have not finished the intro test, make sure you do that first, because I'm about to explain a sort of a game plan that's going to be useful when you guys are solving systems with more than 2 variables. Because the skills don't change. You still need to do elimination and substitution. The only thing that changes is that it's a little puzzly. Sometimes you'll have to solve for a certain variable first, you'll have to eliminate a second variable second. It's more of a planning sort of thing in order to solve systems with 3 equations, with 3 variables. So let's look at number 1, so that way you guys can see a problem that you've already finished. You can see what I mean by game plan. So if I call this my first equation, I call this my second equation. Now I'm going to write these over here so that way you could see them a little bit easier. What I mean by writing them over here is I'm just going to concentrate on the variables. Notice that my first equation only has an x and a y. My second equation only has an x and a y. So without even looking at the problems, ignore them for now. Look at these as variables and thinking of, okay, I'm going to eliminate one of these variables and I'm going to be left with something else. Now you can only eliminate or substitute for one variable at a time. So if I see this, I know my first equation has an x and a y. My second equation has an x and a y. If I were to eliminate one of these variables, and let's say I eliminate y's just because it feels right. Keep in mind I could have done my x's. If I eliminate, and I'm going to show that, okay, this means eliminate or substitute, whatever you need it to be. If I eliminate my y's, notice what you're left with. You're only going to be left with an x, an equation with just an x. That means that you could solve for that x, and after you solve for that x, what you could do is you could go back to one of your 2 equations, plug in a value for x, and then solve for y. So that's what I mean by game plan. Of course, it's super visual. It might take some practice, but what it does, it takes all the hard math to it. It comes up with a game plan. So that way, when you do these tricky problems, well, the ones with 3 variables, you're able to solve a little bit more concretely or have a game plan in order to move forward. So let me show you an example of what I mean by that. So I'm going to call this equation here 1, 2, and 3. So that's equations 1, 2, and 3. My first equation has an e and an f variable. My second equation has a d, e, and an f. And of course, my third equation just has an e. So looking at all those variables, I know that I have an e to find, I have an f to find, and a letter d to find. So it is your job to figure out what all of these. Now remember what your goal is of elimination. When you have multiple variables, your goal is to eliminate one of the variables in order to have one variable left over that you could solve for. So your goal is to find an equation or make an equation that has only one variable. And we can clearly see here that I already have an equation with just one variable. It is equation 3. So knowing that, I'm going to write down equation 3 and then solve for that variable that I've circled there, that I had the game plan. I'm going to solve for e. So in order to solve for e, I'm going to divide by 3 on both sides. I'm left with e is equal to a negative 1. So I know that my e equals negative 1. Now, if I know what e is, notice that all these equations that have e's, I can actually plug in and know what that value for e is. So what I could do here is circle my e's to pretty much tell me visually, hey, I know what these values are, and look for another equation that I could solve for a variable that's going to be by itself, or you'll only have a variable. What I mean by that is if you look at equation 1, if I plug in the value for e, which I found, I'll be able to solve for f really easily. So let me write equation 1 down. It is e plus f is equal to 4. Now again, which value do you know? You know what e is. E is a negative 1. So I'm going to substitute negative 1 in for e and then solve for that equation. I'm going to add 1 to both sides, and you'll notice that f is equal to a positive 5. So, cool. I found what f is. Now I could go ahead and circle all my other f's and other equations, so that way I could kind of go back and analyze again what is left over, what else do I need to find. And we can see here that I need to find the letter d. The only equation that has a letter d is 2, and I can see that I can solve for d because I already know what e and f are. So let's write down what equation 2 is. Equation 2 is 2 times d plus 4 times e minus f is equal to a negative 3. Now again, what do you know what values e and f are? So let's plug those in. E is a negative 1 minus f, which is a positive 5, which is equal to a negative 3. Now it's just algebra 1, right? You're going to solve for this equation. Multiplying that negative 4, you end up with a negative 4 minus 5 is equal to a negative 3. Combining like terms, you end up with a negative 9. Adding 9 to both sides, 2d is going to be equal to a positive 6, and then finally dividing by 2 on both sides, d is equal to 3. So you have now found the values for E, F, and D, and now you can see how that kind of goes by now. This is what I would call a level 1 problem in terms of 3 variables, because you already have an equation that's solved for a variable. It's very easy. When you see these, you should be like, all right, easy points. And you can always go back and check a little bit more too. Let me change colors so that way you see it. Notice that your first equation is E plus F, and that's supposed to equal a positive 4. Well, your E is a negative 1. If you add that to your F, which is a 5, notice that you do get a 4 out. Notice that a little easier one. 3 times E is a negative 1. So if you plug that back in, you would also get it in. You also get that correct. So with all that being said, remember that the main thing about these problems that you have to make sure that you understand is a game plan. When you don't go into these problems with the game plan, it's a mess. You don't get anywhere. So let's go and do some more examples. That way you know what I'm talking about here. So notice that my first equation here, my second, and my third. Let me change colors so that way it's a little more obvious. I'll go with red. So I have equation 1, equation 2, and equation 3. Equation 1 has an x and a z. Equation 2 has a y and an x. And equation 3 has an x and a z. So keep in mind that I'm pretty much ignoring my equations. I'm just concentrating on the variables and asking myself, what would I have to eliminate to get an equation that only has one variable? And I could solve for that variable. So let's start analyzing these problems. So I kind of start getting super remotely on it. I usually always do the first and second equation just because it seems right? You want to start in order. Now, think about this. If you were to eliminate the x's, because those are the only ones that are common, that's the only thing you can eliminate, right? You only can eliminate one at a time, so that means the x's would eliminate. What are you left with? You're left with a z and a y. That's no good for us because we have a z and a y. We need an equation with a single variable. Let's see if we could maybe do something else to kind of get that, to get what we want. So let's look at equation 2 and 3. Now notice here the only variables that these two equations have in common are the x's. So notice that you're left with the y and z again. Now, unfortunately for us, that does not really help us much in that situation. Let's try one more combination, which is the first and the third. And you can see that the better you get at these, the better patterns you see, or the more common things you do in order to eliminate. So notice I can eliminate my x's or my z's, and I'm going to be left with one variable. So my suggestion for you is to start off with, you're going to eliminate one of those, write down those two equations down. So I have negative x minus 5z is equal to a negative 5. That's my first equation. My third equation is 13x plus 2z is equal to a positive 2. And then ask yourself, this is a z by the way, it's a really ugly z, but a z nonetheless. And then ask yourself, which one of these seems a little bit easier to eliminate for me? I can see here that I don't want to deal with that 13 there. So I'm just going to start concentrating on let's go with that one. I think I'm going to go with eliminating my x's. So that way I'm left with a z. If I'm left with a z by itself, I can solve for it. So let's go ahead and do that. Now, if you don't know how to use elimination or anything like that, make sure you go back and watch those videos because it's way too hard to start with the basics of elimination substitution while doing these problems. It's going to be total. So I notice that I have a negative x and a positive 13. The first thing I'm going to do is distribute a 13 because I want that x to be a 13. So let me show my arrows here. I end up with a negative 13x minus 65z because 13 times 5 is 65. And that is equal to a negative 65. Now my bottom equation, I don't have to do anything because I was looking for that 13x in order to eliminate, right? So plus 2z is equal to a positive 2. Now eliminating my x's, I'm left with a negative 63z, which is equal to a negative 63. Dividing by negative 63. You finally end up with z is equal to a positive 1. So your z is equal to a positive 1. You found one of the variables, now you have to go ahead and solve for the other ones. Now, as soon as you get a value for one of the variables, things become easy. You'll notice how easy it was when we did the problem over there, problem number 1. You just got to go back and see what equations fit. So what I like to do is I like to go back. I know a z equals, so I circle all my z's because now I can visually see which equations I could use. If I look at my equation 1, notice I just have an x and a z. I already know what z is. So that means I could solve for that x. So let me write down my first equation. Now I'm going to do it over here so that way I have some space. So my first equation is a negative x minus 5z. Let me write my z a little better. And that is equal to a negative 5. Now, double checking to make sure I write these right, I'm going to plug in my z of a positive 1. So negative x minus 5 times a positive 1 is equal to a negative 5. Negative 5 times 1 is a negative 5, which is equal to a negative 5. Adding 5 to both sides, you can see here that we end up with a negative x is equal to 0. Dividing by negative 1, x is equal to 0. So I have found my x. Go back to the drawing board. Go back and circle what you know. You know your z's already. Your z's a 1. Your x is a 0. So now you can go back and be like, okay, what is left over? What's left over is my y. The only equation with a y is 2, but you can see that you could actually solve it for it in this point because you already know what that x is. So let's start with the equation 2. I'm going to write it right over here. Y minus 3x is equal to 0. Remember, you know what x is already. It is a 0, so y minus 3 times 0 is equal to 0. Negative 3 times 0 is 0, so you're left with y is equal to 0. So that is your x, that is your y, and that is your z. Again, are these problems technically hard? No, they're not hard if you have the game plan down. If you have the game plan down, that means that you are able to solve for those problems, or you're able to solve for them. So, again, make sure you understand how and what I mean by game plan. So what I'm going to do now is scroll this up a little bit so that way we have a little more room to write. You can see that these problems take a lot of space. Now, make sure that you're taking your time. If I made a mistake, make sure you tell me. You will get extra credit. It's so easy to make a mistake on these problems because there's so much algebra going on. So let's go ahead and do these problems. So 1, 2, and 3. Notice that your first equation has an a and a b. Your second equation has a b and a c. And your third equation has an a and a c. Now, again, the more you practice, the better you're going to get at these. So let's start with just what we know. Let's see what we could get rid of in our first and second equation. Now, the only thing we have in common are the b's. You're left with an a and a c. Oh, man. So notice that one doesn't work out. Let's see if we can eliminate another one that's a little easier for us. Let's do, just keep it just routine. Our next one, the only variables they have in common are the c's. If you cancel out the c's, you're left with an a and a b. So unfortunately for us, that doesn't work either. Now, the next thing that we're going to check over here is the first and the third. Now, the only thing they have in common are the a's, and you're left with a b and a c. So notice that there are no equations that you can eliminate a variable and you're left with 1. And that is okay. These problems happen all the time. You're going to just have to do additional equations. So let me show you what I mean by that. Now, it's super important that you notice one thing here, that when you eliminate a variable in these kind of problems, notice what you're left with, and if you could use that equation to eliminate another variable, so to speak. Let me show you. So if I look at my first and second equation, the only ones I can eliminate are the b's. So I'm left with an a and a c. Now, what I like to call this is a star equation because, I don't know, it's just star, right? It's a new equation. Now, unfortunately for us, there's nothing we really can do, but let me change color so you can see it. Look at your star equation, your new one, and your third equation, your original equation. Notice that they both have a's and c's. If you were to eliminate one of these variables, because you only can eliminate one at a time, let's say you eliminate those a's, then you're left with a c by itself. You finally got there. So this is kind of the more tricky problems in terms of, okay, if I eliminate these two variables, I'm left with or if I eliminate this variable, I'm left with an equation with new variables. I could use one of my original ones, and that is how you do these problems. So let's go ahead and do the game plan. First thing I'm going to do is the blue. The blue is telling me to eliminate b's from my first and my third. So my first equation is a plus b is equal to 3. My second equation, is a negative b plus c is equal to 3. Now, whenever I do these problems, I always like to draw a line down the equal sign so I can see my two sides and add what I'm supposed to add to the one side and then to the other. So I can see here that my b's will eliminate because I have a negative and a positive b. Now my a and my c I cannot combine, so I'm just going to rewrite it as whatever's left over, a plus c, which is equal to a positive 6. Now remember, this is your star equation. I'm going to put a star so that way I can locate it. Now, what was my game plan back in the day? What was the green? It's to take that star equation, and I'm going to write it over here, a plus c, and then eliminate the a from my third equation. My third equation is a plus 2c is equal to 10. Looks like I forgot my 6 there, so there we go. Now remember, it's my job to eliminate the a's. Unfortunately for us, we're not going to eliminate right away. One of them has to be an opposite sign. I'm just going to make the first one negative, so that way I can make it eliminate. So a negative a minus c and a negative 6 is what I end up with. A plus 2c equals 10 is my bottom equation, that nothing happens. My a's cancel out. I'm left with a c is equal to a positive 4. So I finally found a c. I know it seems like so much work, but you still got a little bit left. The good thing is you did all the hard part now. Now that we know what c equals, notice that I can go back to my star equation. I don't even have to look back far to find what my a is. So where's my star equation? That's what's also nice about drawing the star equations, because you can always just see them, or you can find them with the obvious stars. So I know my c is a plus 4 is equal to 6, minusing 4 on both sides. A is equal to a positive 2. Now that I know what my a is, I can go back and circle my a's. Now again, remember, you know what your c's are as well, so you can go and circle your c's as well. And notice you have multiple options to solve for b. You can either use the first equation, you can use the first or the second equation, because again, you're looking for b's. You know what the other ones are. I just choose whichever one looks easier. The first one looks easier, so I'm going to write my first one there. A plus b is equal to c. Remember, your a is equal to 2 plus b. I don't know why I wrote a c there. It's supposed to be a 3. That was my original equation back here. Hopefully I didn't confuse you that much. So a plus b is equal to 3. You know that your a is equal to 2, so you end up with 2 plus b is equal to 3. There we go. So minusing 2 on both sides, you finally end up with b is equal to 1. So you know your a, you know your b, you know your c, and now you're ready to move on. Again, where does all this stem from? Or what's the number one skill I would want you to have is this guy here. If you can get the game plan down, all this stuff is just elimination substitution. It's the stuff we covered last week. So that is the number one thing that I think I would want from a student that is trying to master these problems and how to do them. Now, one thing I see a lot of students happen is that they get frustrated because they're like, I don't get this right away. You're starting in Algebra 1. You're getting to a part in math where you're not going to get it right away. You're going to have to work on it a little bit harder and practice in order to understand it. So don't get frustrated. Just make sure that you guys are thinking about what you're doing as you go on and building on what you need. Now, my Promethean board